Hello students, in this video we will be solving 4 problems from exercise 8.4 and under that it is the 5th question, prove the following identities. So the first problem is cosec theta minus cot theta whole square equal to 1 minus cos theta upon 1 plus cos theta. So we have to prove left hand side is equal to right hand side. So let's begin with the left hand side first. Left hand side says cosec theta minus cot theta whole square. Cosec theta can be written as 1 upon sin theta and cot theta can be written as cos theta upon sin theta, whole thing under brackets, whole square. Since the denominators are the same, we can write it as 1 minus cos theta upon sin theta, whole thing in brackets raised to square. Now if we separate them out, we can write it as 1 minus cos theta whole square upon sin square theta, because the square applies to the numerator as well as the denominator. Now sin square theta, as we know, can be written as 1 minus cos square theta. So we'll write it as 1 minus cos square theta. In brackets we can write since sin square theta equal to 1 minus cos square theta. This is the identity which we had learned. Concluded over here. So continuing with equal to sign, we can write 1 minus cos square theta, 1 minus cos theta whole square can be written as 1 minus cos theta into 1 minus cos theta. Okay. The same thing. And 1 minus cos square theta, if you have a look at this, this is nothing but a square minus b square, which can be written as a minus b into a plus b. So if you multiply both together, we'll get 1 minus cos square theta over here. Now if you have a look, 1 minus cos theta, 1 minus cos theta cancels and we get 1 minus cos theta upon 1 plus cos theta. And that is what we need for the to prove this identity. So this we can say is equal to RHS, and this is how we prove the first one. Our next problem says cos A upon 1 plus sin A plus 1 plus sin A upon cos A equal to 2 sec A. We need to prove left hand side equal to right hand side. Let's begin with our left hand side, which is cos A upon 1 plus sin A plus 1 plus sin A upon cos A. So to get the LCM, we will cross multiply and we get cos A into cos A. I'll just write it as cos A into cos A plus 1 plus sin A into 1 plus sin A, whole thing upon cos A into 1 plus sin A. If we open the bracket in the numerator, we will get something like this. Cos A into cos A gives us cos square A plus 1 plus sin A into 1 plus sin A. This is nothing but A plus B the whole square. So we write A square, can write this as 2AB plus B square, whole thing upon, will not multiply cos A into 1 plus sin A, will you just leave it like that. We may be able to cancel it later. Continuing over here, we will leave cos square A the way it is, plus 1 whole square will give us 1, 2 into 1 into sin A gives us 2 sin A, and sin A whole square can be written as sin square A, whole thing upon cos A into 1 plus sin A. Now cos square plus sin square A can be written as equal to 1. So cos square theta plus sin square theta equal to 1. So cos square A, sin square A. The angles are the same, so we can write that is equal to 1 plus 1 plus 2 sin A, whole thing upon cos A into sin A, 1 plus sin A, 1 plus sin A. And here you can write cos square A plus sin square A equal to 1. Reason for why we get 1 over here instead of cos square A sin square A. 1 plus 1 gives us 2. 2 plus 2 sin A whole thing upon cos A upon 1 plus sin A. We can take 2 common between the two and we will be left with 1 plus sin A whole thing upon cos A upon 1 plus sin A. 1 plus sin A is common in numerator and denominator. We can cancel it out. We are left with 2 upon cos A, which can be written as 2 sec A. Same as what we require right hand side. This is equal to RHS. This we will be able to solve the second problem. The next problem is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta equal to 1 plus sec theta into cosec theta. We need to prove left hand side equal to right hand side, beginning from with the left hand side, which is equal to tan theta upon 1 minus cot theta plus cot theta into 1 minus tan theta. Whenever we look to solve such identities, we should look to simplify first. That gives us a better idea of where it is leading us to, and one eye should always be upon on where we intend to go, our target, which is our right hand side, 1 plus sec. So throughout solving the left hand side, we should never lose focus on what we need to achieve, that is equal to right hand side. Okay. So whatever we solve, it should always be in keeping in mind what we need to achieve. Let us do that. Sin tan theta, and once again what I'll do over here, I'll leave tan theta the way it is, and cot theta I'll convert it to tan theta. Cot theta is equal to 1 upon tan theta, because cot theta and tan theta are reciprocals of each other. So 1 minus 1 upon tan theta, and I'll do the same thing over here. Cot theta I'll convert it to 1 upon tan theta, and 1 minus tan theta I'll leave the same. So everything I'm getting in tan theta form. Okay. Now continue with this tan theta whole thing upon, and now I'll take the LCM over here. That will give us tan theta minus 1 upon tan theta plus, and over here this will become 1 upon, so I'll show you the multiplication over here. So we have to convert from division to multiplication. So this will become 1 upon tan theta into, now this is 1 minus tan theta is numerator, numerator upon denominator, denominator is what, 1. So 1 will go on top, denominator will become numerator and numerator will become denominator, 1 minus tan theta. Solve it over here. So once again we'll have to convert this from division to multiplication. So once again this will be tan theta will remain the way it is. So tan theta upon 1 it is into what is the denominator here will become now the numerator this way, and the numerator will now become the denominator plus here. Now we have the numerator, we can multiply, we get 1 whole thing upon tan theta into 1 minus tan theta. Now we multiply here, tan theta into tan theta, we get tan square theta whole thing upon 1 into tan theta minus 1, we get tan theta minus 1 plus 1 upon tan, this is tan theta into 1 minus tan theta. Now I'll make slight adjustments over here. This is tan theta minus 1. So if I want to take the LCM, I'll have to convert this from 1 minus tan theta to tan theta minus 1. For that what I'll do is I'll take minus sign common. If I take minus sign common, the minus sign comes out over here, and what is positive will become negative, that is 1 will become negative 1, and minus tan theta will become positive. I'll show you how. Tan square theta, this entire thing will write it the way it is, tan theta minus 1, and now I'm taking the minus sign common, so this will become minus first, 1 upon tan theta will remain the way it is, and tan theta which is negative will become positive, so I'll write it this way, and 1 which is positive will become negative. Okay. So what is really happening is something like this. Okay. This was what? 1 minus tan theta. If we multiply this with negative, so this what happens is negative sign goes inside, become minus 1, and minus into minus become plus tan theta, which is nothing but tan theta minus 1. That is why we take the negative sign outside. Now tan theta minus 1, tan theta minus 1 is the same. If we want to take the LCM, this is the only thing that is extra, which has to be multiplied with this term. So we get over here tan square theta into tan theta, whole thing upon tan theta into tan theta minus 1, minus 1 upon tan theta into tan theta minus 1. Okay. Now that the denominators are the same, we can straight away combine the numerator. So tan square theta into tan theta gives us tan cube theta minus 1, whole thing upon tan theta minus 1. Now this numerator is in the form a cube minus b cube. You can write this as 1 cube you write, or just 1, it comes to 1. So this is just for your understanding, actually it's not there. So I'll erase this part, leave it this way to avoid confusion. So tan cube theta minus 1. So this I'll write it as a cube minus b cube, can be written as a minus b, which is tan theta minus 1, into a square plus ab, which is tan theta into 1, plus b square, 1, whole thing upon tan theta into tan theta minus 1. In the numerator as denominator we have tan theta minus 1, so they cancel off, and what we get, we just write it down, what we get, equal to tan square theta plus tan theta plus 1, whole thing upon tan theta. I'll erase this left hand side and I'll continue the problem here. Left hand side then, set it here. Now we can individually separate them out, okay, this way, tan square theta upon tan theta plus tan theta upon tan theta plus 1 upon tan theta. Okay, same thing I have written, which is over here. Here everything was clubbed under one denominator, because they have the same denominator. We could have, it was written this way. Now I've just separated them out this way into individual terms. Tan theta and square cancel, we are left with just tan theta. Tan theta and tan theta cancel, so we'll get just 1, and here 1 upon tan theta is remaining. Okay, now that 1 upon tan theta, we can write it as cot theta, because 1 upon tan theta is equal to cot theta. Cot theta is reciprocal of tan theta. Okay, so now the denominator is gone, we don't no longer need the denominator. Now this whole thing can be written as, I'll take this 1 here, plus tan theta, I can write it as sin theta upon cos theta, and cot theta can be written as cos theta upon sin theta. Okay, now I'll just take only this much part, only this part, I'll leave the 1 separate, and if I want to add them up, then I need to take the LCM. So LCM will be, we'll have to multiply sin theta into sin theta and cos theta into cos theta, and we'll get sin square theta plus cos square theta, whole thing upon sin theta cos theta. Sin square theta plus cos square theta is what? Equal to 1. So we write 1 upon 1 plus 1 upon sin theta cos theta. Okay, you can write over here, since sin square theta plus cos square theta equal to 1. Now if you have a look, what we needed over here was 1 plus sec theta into cosec theta. We've got 1 plus, if you have a look, this is nothing but 1 sin theta into 1 cos theta. 1 upon sin theta is what? Cosec theta. 1 upon cos theta is what? Sec. 1 upon sin theta is cosec theta, and 1 upon cos theta is sec theta. So we can write this as 1 plus cosec theta into sin theta, which is equal to RHS. Got it? As simple as that. It wasn't difficult. Over here, this 1 upon sin theta, this can be 1 upon sin theta. I've skipped that part, but 1 upon sin theta, I'll just put it over here, can be written as 1 upon sin theta into 1 upon cos theta, which is nothing but, so 1 upon sin theta is cosec theta into 1 upon cos theta is sec theta. Okay, so this is how we get a long problem, but this is how we solve. So as you solve more and more problems, you will be able to understand which route to take, how to solve, what to keep, what to exclude, what to get rid of. Okay, this happens with practice. Solve another one. Next problem is 1 plus sec a upon sec a, which needs to be proved equal to sin square a upon 1 minus cos. So let's begin with the left hand side, which is equal to 1 plus sec a upon sec a. So sec a can be written as 1 upon cos a, and once again sec a can be written as 1 upon cos a. So we'll first get the LCM here. So this will become cos a plus 1 upon cos a whole thing upon 1 upon cos a. We put this down over here, convert it to multiplication form, we will get it this way, cos a plus 1 upon cos a multiplied by, what is the denominator now will become the numerator, and numerator will become the denominator. Cos a cancels, we get 1 plus cos a. Okay, now this is our left hand side. This is definitely not equal to right hand side, but we'll solve for the right hand side as well. So right hand side equal to sin square a plus 1 minus cos a. Sin square a can be written as 1 minus cos square a, that is from our identity. So we can write, since sin square a equal to 1 minus cos square a. Now this is a square minus b square form, which we can write in a minus b into a plus b. So a minus b into a plus b whole thing upon 1 minus cos a. So we, in the numerator and denominator, we've got 1 minus cos a, we cancel both of them, we are left with 1 plus cos a. Now if you have a look, left hand side we got 1 plus cos a, right hand side also we got 1 plus cos a. You can see, therefore left hand side is equal to right hand side. Okay. So sometimes you have to solve both left hand side and right hand side to get equal to each other. Different situations call for different approaches. So with this we have completed 4 problems in this video. If you have liked watching this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notifications whenever new video is posted. Thanks for watching. See you in the next video.